ODE is called linear. It can be written in that form. إذا أي معادلة ممكن أن أكتبها بهذه الطريقة second order طبعا we call it linear. Now الخاصية المميزة فيها إنه أنا y double prime y prime y all them are linear. linear زي ما حكينا المرة الماضية هي kind of power 1 مش مرفوع لأي power is not in the denominator not inside any function مش مضروبين في بعض. So this is what we call it linear. Again y double prime y prime and y all them are linear. We call it second order because the highest derivative is the second derivative. Now, p of x, q of x, r of x are any function of x. Are any function of x. Again, if we can write it that way, it's going to be linear. Of course, we call it nonlinear if it cannot be written in that way. Now, the two functions p of x and q of x are called coefficients over there. Now, the leading coefficient over here is 1. So just in case it happened that one of the equations you have some function over here, basically you can divide that by that function. Now you just discuss the right hand side over here. The same thing for what we did for first order. If this term is 0, we call this equation homogeneous. If this one is not 0, we call it non-homogeneous. And homogeneous can be reduced in that way. Y double prime plus p of xy prime plus q of xy equals 0. So this is homogeneous, linear, second order ODE. And non-homogeneous if I do have some functions of x on the right hand side. Now, I'm gonna give you some examples of the definitions that we just learned. The first one is going to be non-homogeneous linear ODE. Now, I'm going to discuss first the linearity. You see y double prime, you see y, both of them are linear. Now, the right hand side, you can see I have product of two functions. This is not 0, so this is non-homogeneous. Now, the question that comes to mind, what is y prime? Now, y prime, basically, the coefficient of y prime is 0. So the functions that p of x that we call it just in the previous slide, since p of x could be any function, I choose p of x equals 0. So this could be, for example, 0, and as in the example later, as this example. So y prime the coefficient is 0. So this is non-homogeneous, again, because I do have a non-zero term on the right. And another example is over here. Homogeneous linear ODE. Homogeneous because I have 0 over here. Linear, y double prime, y, all them are linear. This is very clear. Now, if you compare this one to the given function, this is what when I told you that, what if you have something? I do not have any problem if you need to write it in the standard form, divide the whole equation by the leading coefficient, which is x over here, and if you divide it, you're going to get it in the standard form, which is y double prime plus 1 over xy prime plus y equals 0. Now, if you need to find p of x, here we go, it's 1 over x. Q of x is going to be 1. R of x is going to be 0. Now, an example of a non-linear ODE is this one. And you see, it's non-linear for two things at least. The first one, y prime is to the second power. Is been squared. The second thing, those two been multiplied by each other. This cannot be the case. So this is a non-linear ODE. Now, some examples, homogeneous and linear, homogeneous and linear. This is non-homogeneous and linear, and this is non-linear. And it's very clearly, guys, this non-linear for the same thing that we discussed in the previous example. This has been squared over here. This has been multiplied by each other. This is non-homogeneous because I have a non-zero term over here. Linear, it's very clearly. Now 7 over x over here is not a problem. Does not affect your linearity or homogeneity because I could have any function. Now, solutions as we defined before. Now, we call any given function a solution on some open interval if that function is defined. This is one. Now, should be twice differentiable. Why it's twice differentiable? Because I need it for my second order ODE. Means I need to substitute my function in y del prime and y. So this is why it should be twice differentiable. Now, the two derivatives also should be defined. You cannot miss this. And of course, when you substitute your function and the two derivatives in the given equation, the ODE should become identity, means they should satisfy your equation. And this is exactly the same concept that we discussed in the first order.